Welcome. This is the power-assisted quadricycle team, and we'd like to tell you about our Capstone design project. We started with a bare-bones quadricycle and tasked ourselves with the following goals. Enable power assistance, i.e. add a motor to the quadricycle. Allow the user to variably control that assistance. For this, we decided on a cruise control system. Include features in the electronics that will control the power used and protect the system from potential power failure modes. Also, our client does not desire to register the quadricycle with the Department of Public Safety as a motor vehicle, so there are a few requirements there, namely max power and velocity. We are going to make the quadricycle comply with those. And finally, we have to integrate all these extra systems onto the existing framework of the quadricycle. For power assistance, we opted for a brushless DC motor. The particular model was a propeller aircraft motor rated at 750 watts and 24 volts. Its maximum RPM was around 13,000, so we included a 36:1 gear ratio drop so that the vehicle speed is maintained below legal requirements, as well as to get some more torque out of the motor. Cruise control is implemented via a control knob on the dashboard. Turning clockwise will increase the desired speed. Counterclockwise will decrease the desired speed. As power assistance, the cruise control is slightly different from your car's standard cruise control. If the desired speed is faster than your actual speed, the motor will put forth some more effort, up to 750 watts, to help you get to the desired speed. If your actual speed and the desired speed are the same, well, the motor just keeps on keeping on. And if for some reason you decide to go faster than the desired speed that you set, the motor will shut off because the chain moves to torque the drive shaft. Will slip, just like your standard bike will if you coast, but you still move your feet around a little bit on the pedals. To manage the power output to the motor, the cruise control will signal whether more or less power is needed to maintain the speed desired. This, in turn, will influence the duty cycle of the switching signals that are sent to the motor driver. Also, there's an overcurrent protection implemented, which will restart the motor in case of the motor stalling, and because if it stalls, it'll end up drawing current that's on the order of hundreds of amps, which is not good. Finally, a battery recharger was also integrated into the quadricycle so that the batteries don't have to be removed in order to recharge. In Texas, motor vehicles must register with DPS if they can surpass 20 miles an hour or output above 750 watts, which is about 1 horsepower. Keeping in mind that our customer doesn't want this hassle, using motor specs and an appropriate gear ratio, as I said before, speed is limited to 20 miles an hour, and the motor itself is rated at 750 watts, so that's all good. And that way, our vehicle doesn't require registration with the state. Once all the subsystems were completed, we mounted them onto various parts of the quadricycle that made sense, like the user interface is mounted on the dashboard, and the motors near the drive shaft, near all the chains that already exist there for the user to pedal. In addition, we fabricated some mounting frames that allowed more efficient use of some space on the quadricycle. Now we'd like to show you a couple demos from the testing stages.